NASA didn't just go quiet, it went completely silent. Not the kind of silence that happens by mistake, but the kind that feels planned, deliberate, and heavy with meaning. The week the interstellar object known as 3I/Atlas passed by Mars, every data stream, every live feed, every update from NASA suddenly froze. Websites went dark, official channels displayed the same cold message. Due to a lapse in funding, this site is not being updated. To most people, it was just another government shutdown, a bureaucratic pause in a noisy world. But to those watching the skies, the timing was almost impossible to ignore. Because while Earth's agencies went silent, something unexplainable was moving through the night. A visitor from another star, the third interstellar object ever detected, and the first to pass so close to a planet that humans were actively exploring. The first to come within range of cameras, sensors, and rovers. The first we could have truly seen. And yet, when the moment came, the world was blind. Astronomers had first noticed 3I/Atlas months earlier. At first, it seemed ordinary, a bright, active comet with a greenish glow. But soon, patterns emerged that didn't belong to any known object. Its tail pointed toward the sun instead of away from it. Its brightness didn't fade the way it should have. And when a solar storm erupted, a massive wave of plasma that could destroy electronics and rip fragile surfaces apart. 3I/Atlas didn't even flinch. It kept its course, unaltered, untouched, as though the sun itself had no effect on it. Then came the real shock. Its path wasn't random. Unlike the wild, steep angles of earlier interstellar objects like Oumuamua and Borisov, Atlas glided along the same plane as the planets. It wasn't diving through our system, it was moving with it, almost as if it had come intentionally, following the pattern of our orbit, aligning itself with our world. That detail, more than anything, made astronomers uneasy, because nothing natural should do that, not by accident. By early October 2025, every space agency had its eyes fixed on Mars. The red planet was about to witness something no human had ever seen. A foreign object from deep interstellar space sweeping past one of our robotic outposts. NASA's Perseverance rover was prepped for long exposure night shots. The Mars Reconnaissance Orbiter, the European Space Agency's Mars Express, China's Tianwen-1, and the UAE's Hope Orbiter were all positioned to observe the encounter. The data from those instruments could have changed our understanding of the universe. Proof of composition, trajectory, behavior, even possible structure. And then, right as 3I/Atlas entered the zone of maximum visibility, NASA went silent. No updates, no new images, no press briefings. The feeds simply stopped. The rovers and satellites were still running, still recording. Their data stored, their systems active. But the public line went dark. A perfect blackout that began just as the object passed Mars and lifted only days later after it was gone. That silence wasn't total, though. Somewhere in the background, a few fragments of information began to slip through. A handful of researchers quietly shared a frame from one of Perseverance's night sky calibration images, a faint but sharp streak cutting diagonally through the Martian starscape. It wasn't a star trail, and it wasn't noise. It was something moving straight and fast. The angle, speed, and timing matched the predicted path of 3I/Atlas almost exactly. Then, the image disappeared. The post was deleted, and those who tried to mention it online found their discussions vanishing within hours. Meanwhile, the European Space Agency made a vague announcement. Observations of 3I/Atlas are ongoing and promising. No photos, no data, just polite words wrapped around a mystery. So what really happened? Could it all be coincidence? A government shutdown overlapping perfectly with one of the most significant astronomical encounters in human history? Or was it something more? Some researchers believe 3I/Atlas was just an unusual comet, one whose composition resisted solar heat. Others point out its unusual trajectory and resilience, suggesting that it behaved more like a craft than a rock, controlled, stable, and possibly aware. And that's when the silence starts to feel heavier. Why, at the most critical moment, did all public observations cease? Why were other space agencies so quiet? Why did even amateur telescopes record less than expected? Each answer leads to another question, and each question leads back to the same place, the silence. Theories began spreading quickly. Some said NASA had detected something they couldn't explain and chose to hold the data for review. Others speculated that 3I/Atlas emitted a signal or radiation that interfered with satellites. But one thing no one could deny: the timing was extraordinary. For the third time in less than a decade, an object from another star entered our solar system. The first, Oumuamua, reflected light like metal and changed course without a visible tail. The second, Borisov, burned too brightly for its size. And now, the third, Atlas, moved in harmony with our orbits, unaffected by the sun. Each one stranger than the last, each one harder to explain. And every time, the final data, the moment of truth, slipped through our fingers. Maybe it was nothing. Maybe the silence was just bureaucracy, a system pausing itself while something historic happened overhead. But maybe, just maybe, something far older and more advanced than us crossed paths with our little red neighbor that week. Something that didn't want to be seen. When 3I/Atlas passed Mars, the universe didn't make a sound, but silence is never just silence. Sometimes it's a message, a warning, or a secret too vast for us to understand. And perhaps, somewhere in those hidden archives, the truth is already known, sealed away, waiting for the world to be ready. Until then, the question remains, what really passed Mars in October 2025? A comet, a relic, or something watching from stars? But the story of 3I/Atlas didn't end when it drifted away from Mars. In fact, that's when the real mystery began. By mid-October, astronomers expected to regain visibility as the object moved out of the sun's glare. Yet, when observatories around the world turned their instruments toward its predicted path, they found nothing. The coordinates were right, the timing was precise, but the sky was empty. It was as if 3I/Atlas had simply vanished. Some speculated that it disintegrated near perihelion, the point closest to the sun, but there was no debris trail, no fading dust plume, no trace of its existence. For an object of that size and mass, complete disappearance was almost impossible. Others suggested that its brightness dropped sharply, meaning it might have stopped reflecting sunlight altogether, something a natural comet cannot just decide to do. That's when new whispers emerged, whispers of a controlled maneuver. In late October, radio astronomers in Chile and Japan reported faint, rhythmic bursts coming from the general direction where Atlas should have been. The signals were weak, structured, and spaced at regular intervals, unlike natural cosmic noise. They lasted for 2 nights, then stopped completely. The official explanation? Instrumental interference. But among the global community of skywatchers, many weren't convinced. The idea that a fragment of technology, perhaps ancient, perhaps artificial, had briefly crossed paths with our solar system no longer sounded like wild science fiction. Especially not after Oumuamua, which behaved like a solar sail, and now Atlas, which had defied nearly every rule of cometary physics. The silence from NASA and ESA continued for weeks, broken only by carefully worded statements about data integrity issues and ongoing analysis. But the world had changed. Social media buzzed with speculation. Independent researchers, hobbyist astronomers, and even AI-assisted telescopes began pooling their observations, creating what some called the first citizen-led space surveillance network. Together, they traced possible escape trajectories for Atlas. Most calculations pointed toward the outer solar system, between Jupiter and Saturn, where sunlight grows faint and radio signals fade into static. But a few projections placed it on a course that would swing back inward, looping around the sun on a hyperbolic arc, meaning it might return. And then came something that no one expected. On November 9th, a deep space probe orbiting Jupiter, the European JUICE mission, briefly detected an anomaly, a bright, fast-moving reflection lasting less than 2 seconds. Its shape was irregular, its albedo reflectivity, higher than any known cometary body. The direction matched where Atlas would have been if it had changed course. The data packet containing that image was time-stamped, transmitted, and stored. But by the time scientists went to review it, that file was corrupted beyond recovery. Only metadata remained. The only clue to what had been seen was the label the onboard AI had automatically assigned before the glitch: non-gravitational motion detected. For many, that line said everything. In the months that followed, official attention shifted. NASA quietly restored its public feeds, but never released any additional 3I/Atlas data. The Minor Planet Center listed it as lost, and it disappeared from tracking databases. To most of the scientific world, it became another cosmic anomaly, a strange, unrepeatable event. But for those who followed it from the beginning, that explanation rang hollow. How could the most observed, most tracked interstellar visitor in history simply vanish without a trace? Some began to suspect that whatever Atlas was, it didn't want to be found. There's an older theory among astrophysicists, one that now feels eerily relevant. It's called the Watcher hypothesis. It proposes that some interstellar objects might not be random debris at all, but self-replicating probes sent by ancient civilizations to map and monitor new star systems. They would move slowly, quietly, disguised as natural bodies, comets, asteroids, fragments of dust, waiting for signs of life advanced enough to notice them. Once detected, they would observe, transmit, and move on. If that theory holds any truth, then maybe 3I/Atlas wasn't here by coincidence. Maybe it was here because we're finally loud enough, bright enough, and visible enough for the universe to take notice. And think about the timing. The year humanity achieved quantum communication tests, artificial intelligence reached the edge of self-learning autonomy, and multiple nations launched missions toward Mars. That's when the third interstellar visitor arrived, passing not by Earth, but by the very planet we're trying to colonize. Coincidence or contact? Did 3I/Atlas come to observe humanity's next step? The moment we extend our reach beyond our home world? If so, then its silence wasn't absence, it was attention. And perhaps that's why the agencies went dark. Maybe they saw something that wasn't ready to be revealed. Maybe they knew the truth, that we were being watched not from above, but from between the worlds. Today, scientists continue to debate what 3I/Atlas really was: a comet, a fragment, or a messenger from another civilization. But what cannot be denied is that for a brief moment in 2025, all of humanity looked outward together. Astronomers, skeptics, and believers alike pointed their eyes to the same patch of sky, wondering who or what might be passing through. And though the official data may never be released, the questions it raised will not fade. Because when an interstellar object passes so close, so quietly, and then disappears into the dark, it leaves behind more than mystery. It leaves behind a sense that the universe is far more alive, far more aware than we ever imagined. Maybe 3I/Atlas was nothing more than ice and rock, swept from another sun. Or maybe, just maybe, it was something older, something that remembers, a silent witness moving between the stars, watching the rise of worlds and the birth of civilizations. And as it vanished beyond our sight, perhaps it left us with one unspoken truth: we are not alone, and we were never meant to be. What the public sees is something extraordinary unfolding in space while NASA stays silent. And it's in that gap, between legal procedure and public perception, that conspiracy narratives thrive. Imagine this. An interstellar object, 3I/Atlas, passes close to Mars, a planet with orbiters, rovers, and instruments ready to capture every detail, and suddenly the flow of information halts. The silence is deafening. But why? Who decide what the public gets to know? If a NASA spacecraft captured something anomalous, the data would first be sent to the mission science team. Yet, during a government shutdown, those scientists may be furloughed, unable to access the images. The responsibility then falls to flight controllers, whose job is spacecraft safety, not scientific analysis. Even if they notice something unusual in a raw image, would they know what it is? Would they have the authority to escalate it? Perhaps only if it posed a safety risk. Otherwise, the data might simply sit in a queue until operations return to normal. On the other hand, if military or classified sensors detected something, the chain of authority changes entirely. Defense and intelligence agencies control those observations, and by default, such information is classified. Public disclosure requires an extensive declassification process that could take months or years. That's how something extraordinary could exist in plain sight. Not intentionally hidden, but trapped in bureaucratic procedure, protected by layers of rules, regulations, and security protocols. Meanwhile, the European Space Agency operated under a different system. ESA's openness created a striking contrast, making NASA's silence look suspicious even if nothing nefarious was happening. The lesson here is subtle but critical. Silence doesn't always imply secrecy, but it can unintentionally create an illusion of it. While public agencies may pause, there are countless other observers in space that rarely enter public discourse. ESA's Mars Express and the ExoMars Trace Gas Orbiter were actively tasked to observe 3I/Atlas. But there was also JUICE, the Jupiter Icy Moons Explorer, traveling through the inner solar system and potentially capable of post-perihelion observations. China's Tianwen-1, orbiting Mars since 2021, carried cameras capable of imaging distant objects, though no official reports were released. Similarly, the NASA Psyche mission, en route to a metal-rich asteroid, may have opportunistically collected images. While the geometry was challenging, it illustrates that numerous spacecraft have the potential to observe unexpected targets. The uncertainty around whether they did adds another layer of intrigue. Then there's the realm of classified observation. Military radar, like the U.S. Space Force's Space Fence, is designed to track satellites and debris in Earth orbit, but could such systems detect 3I/Atlas, tens of millions of kilometers away? Technically, sensitivity drops dramatically with distance, making radar detection improbable, yet the existence of these systems leaves a question mark. And what about space-based optical systems, like the National Reconnaissance Office's spy satellites? Known to operate with Hubble-class optics, they could, in theory, observe large interstellar objects. If Atlas was flagged as anomalous, or if an automated system detected something unusual, the data could exist in channels that remain completely invisible to the public. While this is speculation, it's grounded in the operational realities of modern space surveillance. Just because the public doesn't see the data doesn't mean it doesn't exist. It's essential to temper speculation with realism. Many rumors online claim that military assets tracked Atlas and classified the findings immediately. These stories, while fascinating, remain unverified. There are no leaked documents, no credible whistleblowers. What is verifiable is the principle of data asymmetry. Different agencies operate under different mandates, and only a fraction of what is observed publicly makes it to open access datasets. ESA openly announced its observation plans, while NASA's communication silence during a shutdown created a perception gap. Military and intelligence assets may have seen something extraordinary, or they may not have. The truth may remain forever unknown to the public. Yet, science has a self-correcting mechanism. When multiple datasets are eventually released, independent observers compare them. Brightness, position, orbital trajectory, spectral features, all should match within uncertainties. If the records align, it confirms consistency. If they diverge, questions arise. This cross-check system is how science eventually forces clarity, even when some data remains hidden. Let's consider the Mars proximity effect. At 30 million kilometers, Mars' gravity is subtle but measurable. Astrometry could detect slight deviations in 3I/Atlas trajectory, offering a natural experiment in orbital mechanics. Mars' weak magnetic field, combined with its thin exosphere and interaction with the solar wind, creates a bow shock and magnetotail. If 3I/Atlas had passed through closer regions, subtle effects on the comet's ionized particles might have occurred. Slight distortions, shifts in brightness, or spectral changes. Instruments like ESA's HRSC or NOMAD could detect broad-scale variations, while surface structures could not be resolved at that distance. Changes in overall activity, gas production, or brightness spikes would be observable. Even natural phenomena, like comet outbursts, would appear as sudden brightening in wide-field images. Solar wind and space weather add another layer. Coronal mass ejections striking comets can trigger activity, increasing brightness temporarily. 43I/Atlas. Solar events around the Mars window could explain observed variations without invoking exotic mechanisms. Still, the data asymmetry persists. While ESA may eventually release their observations, NASA's shutdown delayed public insights, and classified systems may hold additional information that will never see the light of day. This creates a perception of secrecy, even if no intentional concealment exists. It's a tension between procedure and transparency, one that shapes public perception more powerfully than any single observation. From another perspective, the Mars passage itself might reveal subtle opportunities beyond gravity and plasma interactions. Dust particles from the comet, while sparse at such distances, could theoretically be captured by sensitive instruments, offering information about composition or particle dynamics. Brightness variations and color changes could indicate chemical properties, jet activity, or outgassing patterns. Even without surface resolution, we gain insight into structure and behavior. ESA and NASA instruments, combined with Mars rovers, could collectively create a multidimensional snapshot of the event, capturing nuances invisible from Earth. The broader point is this. 3I/Atlas passage highlights the complexities of modern space observation. Legal procedures, bureaucratic chains of command, agency mandates, and international collaboration all intersect in ways that shape what we see and what we don't. Silence does not always imply conspiracy, but it creates fertile ground for speculation. Bureaucratic delays, classified data, and instrument limitations are sufficient to create a gap between reality and public perception. Yet, within that gap lies fascination, curiosity, and an urgent reminder. The universe moves on,